Good evening and welcome. It is I, your ever-present astronomer, who just actually a floating head. That's all I ever am. It's SkyTour LiveStream, and I'm here with Daryl Mason. Hello, Daryl.
Hello, Mark. Hello, everybody.
How are you guys all doing? It was a beautiful day here. Anyway, we were in the 70s, and it was nice here. You know. Now tonight is a very important night because not just because we have Neptune in here, that's Neptune right there, more so because this may very well be the last stream, not ever, but the last stream before we go live in Arizona, because tomorrow I'm off for the rest of the month filming, and then when I get back on the 23rd, I'm going to be here for 7 days, and during that time I will be getting all the equipment sent out to Arizona, and then we will spend time installing in the observatory, which is ready and waiting. You have no idea. This is long coming, long time coming. And Marianne is off because she just got here and now she's leaving. All right, I understand. She has to be up at 3 in the morning because she's a police officer. I know. I was made to get up at that same hour to go in one time with her and ride around all day in the car. Yes, it was fun. And she's still listening. I know she hasn't quite gone to bed yet. So anyway, good night, Marianne. You have a good evening, and we'll talk tomorrow, I'm sure. And I do want to say hello to everybody else who's here. I see that Justin came by, and he's out there lurking. We have Amos Cardoza's here. Renee Cruz is here. We have Bernie Dodge. We have me. I'm here. I believe it or not, I'm here. And we have Daisy and Zoe Amethyst. And Lane is here, and she brought cookies for everyone. Right, Lane? That's right. She brought cookies. And so, that said, we'll have a good time.
Cookies? What kind of cookies?
Yeah, what kind of cookies, Daisy? Let me know what kind of cookies she brought. And hey there, Gina is here, Gina Leone. And Tara, of course, is here. Carl, our ever-present KGRA host for Behind the Obsidian Curtain, Friday nights at 7 p.m. on kgraradio.com. She's right out there watching as well. You also have heard her voice here a number of times. She's been on with us. And who knows, maybe we'll bring her in again. I don't know, Daryl. We'll leave it up to Daryl. Daryl has to make a decision. And I don't even know if Carol wants to do this. But we're just messing with you, Carol. And Tim F is here. How you doing? And
What's my fault? It's not my fault. I didn't do anything.
No, I was saying.
Somebody saw me do it. I didn't. You can't prove a thing.
Okay, that's right, Bart Simpson. Nobody saw me do it. You can't prove a thing. Yeah. Oh. So yeah, and I think that tonight it's a beautiful night here. I mean, we've had several nights of clarity, and I have to tell you, the skies really were conducive to taking some really pretty photos. And one thing I want to do is just kind of show you briefly some of the photos that well, it was actually just me because I had the observatory open alone, and I was just doing this to try and have a private night of photography, just to get some uninterrupted shots, to try and get some real good photos of stuff. And I will give you an idea of how that turned out. You might like it, you know. And let's see. Okay, we did this. I showed a couple other folks this today, but this should be here. Look at that. This is the elephant's trunk. That's what it looked like the other night, actually last night, and I couldn't believe it. And I have the elephant's trunk is a dark nebula. You can see it here. It's really dark up in here. This is molecular molecular material in here, usually diatomic hydrogen, H2, you know. And then there's some excited ionized hydrogen, which is responsible for the red glow. And these are the things from within which planets will form and other stars. And this material is throughout the galaxy. The galaxy is replete with this material. And this is a beautiful one that is just sitting right out there. Look, and it's in the northern sky. And this picture was 1 minute long. I didn't want to make you sit through 20 1-minute shots, which is why I did it yesterday. But look how beautiful that is. It is stunning. And
it is. That's something.
I was just beside myself with how that came out. It was just so pretty. And that's in Connecticut. Wait till we do this in Arizona. I shake and I shudder thinking how beautiful this might be. And it's just incredible, you know. So the Elephant's Trunk Nebula was one that I used to never even try for, because I figured it's a dark nebula, as you can see, a dark nebula. And I just didn't think we would ever get anything if I did this. And boy, was I wrong. I didn't realize. You can almost see the three-dimensionality here. You know, this is obscuring the stuff behind it, this part. It's just amazing. So this was last night's shot, and the raw shots, if you want to see what a raw shot looks like, this is what it looks like before processing. Look at that. Do you see an elephant's trunk in there? Yeah, I didn't think so. But when you actually look at the finished product, right, you actually see that this comes from that other one. So that's what's inside of the raw data we take. And I used a new technique, by the way, which I told Daryl about. Let me just take a sip of water here. Yeah. and what I did was I shot this with the camera at a very, very high sensitivity rate, very high ISO, as it's called. I shot the cameras. Now this camera goes up to 409,000 ISO. When you take pictures with a camera, typically it's like, 400 ISO or so, and then maybe a little lower, a little higher, depending. But I shot this at 102,000 ISO, and that promotes a lot of grain, a lot of noise, a lot of digital noise. And when you saw the other photo, well, you could see that. There's a lot of noise in this image. All right, that's actually a stacked image, okay? But this is the raw image. And if we zoom in on the raw image, you can see all this weird noise. It almost looks unusable, doesn't it? All right, but it's not. It's not unusable. It's actually able to produce this right here, And yeah.
Excuse me, I'm sorry.
No, go.
I remember, I think I've seen you image the elephant's trunk before, and the change is just remarkable, the difference. That really jumps out at you.
Doesn't it, though? Yeah, and Daryl, I think you're right. And by the way, hi, Catherine Affinen is here. Hello. I'm glad you came back. We're here on Clear Nights, Catherine, and this is the last stream before we go live in Arizona, and that's going to be at the end of the month. So I have to be away doing some film work for the next a couple weeks until the 23rd. Then I'll be back to pack up and send stuff out. What I did was, going back to how I did all this, I used a very high sensitivity, very high ISO, like I said, 102,000. But then I employed a company called Topaz Labs, and I say I bought their product, which is a noise removal system that uses artificial intelligence to very smartly and cleverly remove the noise without hurting the data. And I used the Topaz products. I used several of them actually for this. And the one thing that the Topaz products do is it allows me to take these very high ISO shots, and instead of getting this with all this noise you saw, it removes all that noise and allows you to get a much cleaner stack. So I took 10 or so of these images, All right, and they look like this. This is what they look like when I took them. 10 of those. You can kind of see the trunk right here. You can sort of see it. Okay, and then I took 10 of those, and then when I stacked them, it looked like this. Again, taking out all of the noise, you get a much cleaner final frame that you then can process. Now you can actually see the elephant's trunk a little clearer here. See, it's pretty clear now. However, you see these vertical lines. Like, what are those? What's that horizontal lines? Well, in order to take a proper picture, we take a photograph for a certain period of time. Then we have to move the telescope a little bit and take another one. Move the telescope a little bit, take another one. And we got to go kind of in a diagonal direction. Why? Because what happens is the noise that we see on the photos, like this here, this noise, this systemic noise, can actually pile up on itself. And if you just take the same photo over and over and over again, well, because there's mild drift in one direction or another over the time at which you're taking the photos, you get this line appearing, and it looks like there's rain falling between you and your object out there. And so that is something that we don't want. So by going and doing these random motions left and right, when we stack, we don't get the rain. See, there's no rain here. If we zoom in on this, we just have the generic noise. We don't have the rain. All right, and that's the problem that we want to avoid. So when you process that, you get this. You don't get anything that has a noise in it. So this is the elephant's trunk. Now there's another one that I took as well that night. And when we're in that part of the sky, I have to do a certain number. Like, for instance, I always take a picture of the bubble nebula. Okay, here's the bubble. Okay, you got to take a picture of the bubble. It's just beautiful. It's a Wolf-Rayet star, right about here actually, and it's blowing a big bubble. It's also put another one out here. Okay, over time, very hot stars. Gonna go supernova eventually. Right. So I took a picture of the bubble, and then, not to be outdone, I did indeed do something called the Flaming Star Nebula. And look at this beautiful nebula. This is just yeah.
I'm sorry.
No,
it just looks like a really landmark change. It's like you're better able to make use of the higher ISO settings of the camera that you never did or could before.
And I wouldn't. You're right, Daryl. And the new techniques are gonna be a standard for us. Now we'll take lower sensitivity shots, of course, because that's what you need sometimes. Like if you're taking a picture of Neptune, you won't ever use this kind of ISO. But look at the beautiful tendrils of gas. This is the blue scattered light reflection nebulas within this nebula. Look at these beautiful arches and these concentrations of hydrogen emission. When we've done this nebula before, you've seen this section a little bit, and we saw this little tendril going up here. Lost to us was this outer area here and this outer area here entirely. And we kind of saw maybe just a brief hint of this. Never before have we been able to see things like this. So, you know, it's suffice it to say that we're improving our techniques all the time, and we're trying to become better at what we do, you know. And I'm totally in love with the technique, I have to tell you.
Well, that's really something.
It's beautiful, isn't it? And
it is.
And it's something I chanced upon when I looked at the images and said, look, I've got to be able to work with these noisy images. There has to be a way to get rid of the noise. And I started looking for noise algorithms to get rid of all that graininess. The noise is the grain, like you've seen in grainy movies. That's what this is. So in the digital world, we get noise. In the film world, we get grain. And the faster the film, the higher the grain. In the old days, those of you that remember Tri-X, which is a black and white film, it had some grain, 400 speed versus 100 speed film. And this is the equivalent of 100,000 speed film. So you can imagine how much grain we would be and how much grain we should see, but we don't. Now, just a little, there's a little thing here. I just want to do one little thing. There's another. Go ahead, Daryl.
That's amazing. I'm sorry, I'm just agog at the whole thing.
Isn't this beautiful?
Would it really, if you still have your old files, would there be any advantage to going back and running them through the noise reduction program, or I guess they wouldn't be at the higher ISO that you're at now?
No, they wouldn't be, you know, and I thought about it, you know, I thought about what can I do with these? Can I actually, I've actually run the old ones through the noise algorithm as well, and they do look much better. I'm just, it's just beautiful. Yeah.
Well, time to wipe your hard drive and start all over again.
Yeah, I know, huh? Oh, yeah. So this was the nebula along with the other one, Elephant's Trunk. The flaming star was beautiful. And then I did another one, which I've never been able to do. Never been able to even see it. All right, because of the bright star that's nearby, and it's this one. It's the Gamma Cass Nebula. I didn't show you this one, I don't think, Daryl.
No, I don't think so. You said you took Gamma Cass. I didn't see it though.
Yeah, no, I finished processing late. This is the entire nebula right down here. It goes all the way down and around, and this is Gamma Cass, and it's a star that's causing this hydrogen gas to emit or glow because of the electrons being ionized from the gas, and then they go back down into the atom and give off light when they do. And then down here on the lower left, you see a scattering reflection nebula down here, and some of this diffuse nebula here, as well as here and here. Look at how this is just such a beautiful region with these beautiful stars and the beautiful nebula. Again, this is something that was not available to us, in the past until, I said, the camera goes up to 409,000, and I've been using 51,000 as the highest maximum because I wasn't able to process out the noise very well. But now, using the Topaz denoising system, which, by the way, was all of maybe $25 or $20, if that. I'm telling you, you should get it, Daryl. If you're gonna do pictures, this is what you use.
I'll leave imaging to you. Thanks.
Oh, I'm sure that you want a record of some of the things you see, but this is the Gamma Cass Nebula. So I took that yesterday as well. So it was just a really, really nice night, and now tonight I've got the camera settings set up so that we can see Neptune right now. This is Neptune right here, and if we zoom in, you can actually see that little dot right next to it. That's Triton, Neptune's moon, Triton. You can see the bluish hue of Neptune there. And Neptune's just a little tiny dot in the telescope. So,
Mark,
yeah.
I don't mean to keep interrupting.
No, that's the best way to do it, Daryl.
Officially, Space inquired about. He says he needs to know how to do mosaic shots of the moon.
Oh, yeah. That's a little bit tricky because you want to try and do the mosaic shots right back to back on each other, so that you can keep the time of the shot close to the time of the last shot close to the time of the first shot. Because otherwise, you'll have trouble matching it up. A lot of things happen as the moon moves, it rotates. And we can assume I don't mean it rotates. As the Earth rotates, the moon appears to rotate in the sky because the Earth is rotating. And that changes the position angle of objects on the moon relative to your telescope in mere minutes. So you have to be, willing to align everything, which I'm guessing you would be.
All I could say is, officially, Space, have you tried just shooting a prime focus image of the moon first? You should be able to grab the whole image.
Well, it depends what he's shooting, but
He's using a Celestron Next Star. I don't know what aperture it is. If it's f10, if he's shooting at f10, the moon may be a little bit too big for the field of view. But if you can get an f6.3 focal reducer, you can certainly grab the entire moon in one shot.
And I think what he's talking about, maybe he wants to use a Barlow and get like this, make a high resolution image. Now,
well, yeah.
Officially, one you could do. I know what you're talking about with a Next Star Celestron mount with a fork. You might not have the clearance, is what you're probably thinking. But the focal reducers, for instance, are very small, and you might just need another inch, basically, of space. I have on the back of our 10-inch system out in the observatory here. Yeah, we want to make sure that, when you take a picture, that we have enough clearance to go under the mount as needed, especially for a remote system. And I've been talking to people recently about that for this particular system, and the biggest thing is trying to balance the scope. You have to make sure that the scope is balanced. So when you take off all the locks that hold it in place, which you need rigid and held in place so that you can guide to the stars the way we do in SkyTour LiveStream. When you do that, if you unlock all the mounts, the telescope shouldn't swing down because it's top heavy. It shouldn't rotate to one side because it's side heavy. It should just sit there. And balancing the scope is the quintessentially the most important thing to do if you're going to have another telescope on top that's guiding, which we do. And that's the thing that we try to get done here. So we have we're still on a learning curve too, even though you can be an astronomer, okay, but you may not be a telescope operator. But my history with large telescopes, especially observatory-based telescopes that are so big the entire floor has to move up and down to meet the telescope, has not been stellar, you might say. No pun intended. I've just had yes, Kathy, libration, you're right. Yeah, that girl's smart. I haven't had the best experience in some of the big observatories. It seems like every big observatory I've used, I've damaged something. I get cold, in the winter it's cold, and you're doing a program in there, it's chilly, So anyway, we have Neptune up here, not just blank stars. That's our Neptune, and it's right there, and we'll take another shot. Let's come down to 3200 and do 25 seconds. Okay. So Marston's here. Hey Marston, how are you? Ronald's here. Kathy Pernasek is here. And who else has joined us that I missed? Terry Groff. Hey, the Groff man is here. All hail the Groff. He is in the chat. Alright, so there is our view, and let's see what we've got.
I mentioned in the chat, if you look around on YouTube, later maybe, or in another window, NASA has some absolutely excellent long-time imaging over like the course of a year, where you can see the moon's lunar motions, the librations and nutations and all the different things they call it.
Yeah.
You can watch it from month to month to month over the course of a year and see how the moon moves back and forth and
does a dance,
top to bottom. It's a really super videos.
Just imagine you take a picture of the moon every night throughout its cycle, and lots of pictures of the moon throughout its cycle, and then you put them all together, and the moon does this dance in the sky. It's really cool watching it do it.
Yep. Goes east to west a little bit, and north and south a little bit.
Yep.
And because of that, we actually get to see more than half of the moon. The one face of the moon always faces us, but because it rocks around the edges like that, over the course of time, we get to see about
50 something percent, 54%.
Yeah, I want to say it's like about 9/16 or 5/8 of the moon, something like that. It's really cool, though.
Yeah.
And that's from a combination of the moon being in a elliptical orbit and what's the other one? There's two motions involved, and that's the one I can think of offhand. We get to see around the edges of the moon, though, over the course of time.
Well, there's libration.
Libration, and I think there's one called nutation.
Yeah. Yeah. And that's what you're searching for, I believe.
Yeah.
Okay, so there are a couple new faces out there. Just so you folks who have never been here can just see real quick, I'll tell you what's going on here. This left side, right up here above my head, okay, that is the telescope control cluster. We have the telescope control itself. We have the telescope computer, the focusing system, and this down here is the filter wheel. We have a number of filters in there. Okay, right now you can see that it says narrowband 2, right? That means that we're looking at a somewhat wider swaths through the entire spectrum of light coming from us, from space. And we have a filter that's even tighter. That's called narrowband 1. That's this previous filter, and you can access it by hitting that left button there, and you'll see it moving, and then you'll see narrowband 1 show up. Okay, notice you don't see any stars anymore. That's because we're focusing on tiny little slots in the spectrum, and if the starlight isn't in there, we're not going to see it. Okay, and we use that for doing deep sky nebulae in particular, because that's what that filter was for. Deep sky 2 here, in that narrowband 2, is actually a filter that's used for doing a lot of nebulae, but we also do star clusters with it, and it knocks out almost all of the light pollution that we might get, but narrowband 1 does an even better job of that. Now, filter number 3 is a gradient filter, which is just a spectral filter, and we can see the spectrum of what it is we're looking at with that. It's sort of just a grading. We just see effectively a rainbow, but you know, when I look at it, I can see lines in it that indicate what chemistry we're looking at, but it's really kind of a low resolution version. And I mentioned before, over here in this little cabinet behind me, which you can't see, I have a much higher resolution version of a spectrograph that will be on the telescope that goes back in this dome here in Connecticut, after this telescope here in Connecticut is put in place in Arizona. So the telescope that we've been using here, the one you see in that image over on the right, okay, that is the system that's going to Arizona. All the remote system functionality has been worked out and operated on here. And so I run the dome from here in the house. I don't go out except to move the dome. I didn't motorize it because that dome is getting converted over to the same type of building that we have in Arizona. And that building, by the way, was completed thanks to Marianne, Rob, and Tara, who are in the audience. Or actually, Marianne went to bed. Okay, you silly girl. And Tara, on the other hand, is out here, and she was the person cracking the whip out there to make sure that our contractors did what we wanted. And you know, she's such a beautiful person. She was able to stand out there in the desert heat of 102 degrees or more every day, and was able to coax people that probably didn't want to be there into doing the right thing, and they did a really nice job, I have to say. Great contractors, you know. And one of them actually got kind of excited about the fact that he was building a building where the roof just rolls off. He's never made a building where the roof is not part of the building, integrated into the building. Well, now he did. And that was pretty cool. You know? Somebody call you Farrell? Oh, Catherine did. Okay. I think she missed. I see what happened there, Daryl. Catherine, I want to welcome you to the stream. Thank you for finding us again. We enjoy your company. It's really nice to have you out here. Okay, so we're going to be finding some other things to look at. So that's the screen. That's the camera control, like I said, over here on the left side. That's the telescope control, rather, on this side. I'm down here. Hi there. And over here is the camera control cluster over here. This is the most important thing we look at here. This is the time of the exposure, 25 seconds. This is the ISO. This is the sensitivity of the sensor that I have it set to. Right now it's 3200. And then down here below that is the peek into the dome. So you can see the telescope as it looks right now. So I will definitely, after tonight, I will definitely be working on getting all this stuff packed up and off to Arizona. And I think we're in pretty good shape. The telescope did one weird thing today, which I can't explain. I'm just hoping that was a weird quirk. And we'll see. So anyway, there we go. And I think that that gives you a good understanding. Now, if you want to see where we are in the sky, well, that's what this is for. This is our wonderful telescopic planetarium view. And we use this to see where we are in the sky. Okay, and I think that most people would really like to see more of the sky here. But what we do is we end up looking at different objects in the sky quite a lot. And we do have some galaxies up tonight. And Daryl had actually suggested some. And we will probably do that. We'll probably look at those. So, moon. Who says moon's up? The moon's not up. What the heck's going on? This is absolutely incorrect. You see that, Daryl?
I'm sorry, I was muted. I was typing.
That's okay.
Who said that?
Yeah, I'm looking at the sky and I'm like thinking, why?
Oh, the moon should be around third quarter now. It probably won't be up till midnight.
Yeah, I know, but here it shows it up. So I think we had something go crazy here. Let me just go fix that just in case our time got messed up. And it did.
Yeah.
Okay, and it's actually, I see, look at it, it's actually, okay, our time has gone wacko. That's not good.
That happened a while back a couple of times.
Yes, sir. Yes, sir. It did. And I think that, all right, here we go. All right, our time has been reset. I can't believe I must hit the wrong key. Oof, that's more like it. Okay, so, yes, that's Mars up there. Mars may or may not look impressive tonight. We can look at it if you want.
If you want.
Okay.
I mean, it's almost a month past opposition now, but it's still relatively close in space.
Yeah.
It'll be a little bit smaller and a little bit dimmer, but just a little bit.
Yeah.
Last I heard, it's still about 20 arc seconds in diameter.
Okay. Well, to do that, I need to go move the dome. So, can you entertain while I do that?
I'll try.
And just so you know, folks, when this gets converted to the roll-off roof, like the Arizona Observatory, there will be no need to go out or do anything, because it'll work. I won't need to worry about it. So I think that's a really good thing. So, because I believe in remote access, I do. And I want to bring astronomy to people remotely, and that's what this is all about. That's what SkyTour LiveStream is about. Is trying to get the remote capabilities in your hands. So I think, and I think that well, okay, as Catherine says, when is it on? Is it on like all the time? We're on in clear weather, and most clear nights I will be streaming. Okay. Now, I own a business that does visual effects for television and movies, and I'm also an astronomer, so I kind of have I'd say a number of professions. But one of them is that I have this raging passion to spread astronomy to the people out there. Someone has to do it. And if it was somebody else, I'd say, great, let's watch them. And I do, actually. You got Paul and Keith with P&K Space Imaging. They stream the moon in a most fabulous, fantastical way, and the planets. And Paul and Keith will be sharing our space in Arizona. They have agreed to put a telescope out in there with us. We're going to have 2 telescopes there. One will be ours, one will be theirs. And there'll be a 3rd telescope there as well. That 3rd telescope is going to be the Mystery Scope. That is a wide-angle telescope that we're installing so that we'll be able to drive all over the sky and do phenomenal wide-angle panoramas of the night sky. I mean, you can't just look with, a really tiny, small field when you go to Arizona. Sometimes you just want to see the whole view. And just imagine, we switch over to one particular telescope, okay, with a click of a button, and we capture all of Orion in one shot, all right, with all of its beauty. And then we go in and with another telescope, and we start pulling out, oh, this is the Orion Nebula. This is the Horsehead Nebula. Look, there's the Flame Nebula. Look at that. This is the Rubber Stamp Nebula. Yeah, look, the Witch's Head. I mean, all these things that exist in the constellation as separate objects, we will be able to see all at once with the wide-angle shot. And it really, really comes out nice, Hey there, PG. So we'll be doing that. That's something we'll be doing. So that said, I do want to show you guys one other thing as well, and I'm hoping that I can do this. Let's see now. Okay, this will work. So this was the start of SkyTour West. This is Maddie. She's a trained anti-snake dog because there's rattlesnakes out here, and she will make short work of a rattlesnake. She went to school for it, and I'll tell you, and she's on the property. She lives with the scientist who owns the property. But you notice that area behind here, this is all cleared space that was 5 acres cleared so that we can put our observatory on there. These are great people. Yeah, and there I am saying, hey, the pad is done. And it's only the beginning. This is the guy that owns the land, and this is Tara, who is in the chat tonight. Okay, pretty amazing. So we actually got some good stuff, and this is the overall view. Okay, I know that looks like grass, but there's a lot of it's desert scrub out there. Okay, those are saguaro cactuses out there and mountains and stuff. But look how blue the sky is right to the horizon. It's gorgeous out there. So this is the site. All right, and so we will be getting some gorgeous shots. This was a picture that I saw. It was unfolding just as I was setting up on the pier for an evening of photography not the pier, but the pad for the first time. And this picture just kind of floated into view, and I was like, look at the moon. That's a young moon. It's just showing up. And these saguaro cactuses right there. And I said, oh, I gotta take a picture, And so that's what I did. And this is just a beautiful location for that, So it wasn't bad at all. And then as we moved forward, we started to build the building, and building the building was accomplished over a couple of days. Okay, and I don't want to bore you with that, but this is like an example. Getting the building started up and built. Okay, all right. That's the beginning. It has 5.5 foot tall walls, and then it was metal sided. We metal sided, extra expense, but you know what? In the desert, you get fires, and I know it sounds crazy, but we do get fires out in the desert. And Tara, the person with the whip to keep these guys going, okay, was lounging here in the shade, as you can see. She wasn't lounging; she was working really hard. And so we got the building built, and these guys did a really nice job. Jesse Casso was his name. He did a great job, and he came down. He drove 100 miles to do this job, and he's not desperate. He just thought it was a great project, you know. And then he ended up building it, and then we actually put rails off the outside of the building, and I'll show you as we go. That's the little tiny door. There we go. So these are rails, and then the roof, which you see over here on the right on the ground, goes up on top, and we have an ordinary garage door opener, tested and tried, you know, over many years, and we had that hook up to put together and take the roof off and on the building, and it works like a champ. It's really pretty, and it has a nice vent in the ceiling too. It's not a flat ceiling, it's actually slightly pitched. See, it's higher at this end than this end, slightly pitched, which is really good. And it's not pitched toward the inside of the observatory when it's off, it's pitched away. So the stuff won't roll off into the building, but it'll roll off outside. So that's the observatory. Now we ended up getting some really, I just want to show you some of the shots. I'm going to show you something you haven't seen before. Okay, this. Okay, let me just show you this in a better way here. Okay, this image, okay, is telling a little story. This is the Milky Way there. Okay, this is the sunset. Daryl, have you ever seen the Milky Way and the sunset in the same shot? I mean, you probably have, depending on the pictures you take. But the sun had set about 10-15 minutes earlier. Okay? And some folks turned on their lights, you know, and far away. These are actually far away. And with the sunset glow, we actually still had Milky Way. So it's really so dark out there. It's just beautiful. And the clouds, look, when we see clouds, okay, these are illuminated by the sun, but when the sun goes down, these clouds turn black. They're not illuminated by ground lights. Like on the like here, and in most of your places where you guys are, you would actually see, you know, clouds in the sky at night, and they would look kind of reddish white, you know. But the clouds out there are black because there's nothing to illuminate them from below. So it really throws you off. To be honest, it's like, is that a dark nebula? A dark nebula I've never seen before, you know. So it's really pretty out there, you know. It is. And then the let's see, the sky. That's the Milky Way. But let me see if I can find another shot of the finished. Well, that was kind of the finished one. Well, here's what we did. Let's just show you. Okay, we installed the garage door opener in there. This is the roof off the building, and the garage door opener is extended out through. You can see it going outside to the end of the pole runs there, and it takes the roof on and off. And that's Craig adjusting it and getting it set up. And they took a picture so I could see how far away it was, so I know how to plan for where the piers go. Very thoughtful people. You know, they think of everything out there. You know. So yeah, and that's what it's doing. And that actually shows you the post, and now you're under the roof outside. You know. So there you go. That's kind of a neat little tour of SkyTour LiveStream West right now. And there's video too, and I don't know exactly where the video is. I guess maybe it'll be here. I'm not sure. It's okay. Anyway, so there you go. So now I will follow through on what I said before. I'm going to go move the dome so we can look at Mars, because Daryl's going, I want to see Mars.
Well, we don't have to.
Well, it'll be smaller, like you said, but we can try it. All right. So you'll see the dome move down here in this image. I'll make it larger for you. All right, so I'll go out and I will move that, and I'll be right back. Okay, Daryl?
Very good.
I'll be right back.
What can we talk about while Mark's gone? Martian solar astronomy. Not even getting into the imaging of it. As I said in chat, I just, I have a couple of solar filters, full aperture ones. They're for white light viewing. If you look through the telescope, it'll look either white or kind of a yellow color, sometimes almost orange. But it's basically only letting white light come through. The kind of things you see then are sunspots and solar granulation. That sort of texture you see on the surface of the sun, those little bitty kind of nodule-looking things. And if you watch them over the course of time, you'll see those the granulation change. It's as they're little cells of hot material coming up through the cooler stuff on the surface. And they slowly change constantly as they boil up. And when you see those little granules, they may look tiny, but the sun is so big that those things are like comparable to the size of the state of Texas or the country France, stuff like that. So they're really pretty big. The sunspots themselves, sometimes there's an active sunspot group on the face of the sun right now. And the whole string of sunspots is like 100,000 kilometers long, if I remember correctly. And just the one biggest sunspot in the whole group is bigger than the Earth, diameter-wise. If you like to see such things, there's a website called spaceweather.com. Their content changes like daily almost, so you have to visit it often to see. But they've had some really great sunspot images up of that new group lately. And we are moving into the new sunspot cycle now. The sun was blank for a long time. You'd look for weeks or months on ends and there would not be a single sunspot visible. But now the new solar cycle has started. Magnetic orientation has changed from north to south, I believe. And hey, we're starting to see sunspots again.
Yeah, that's really nice. Maybe we'll actually, you guys, you can hear the telescope too. Maybe we'll actually be able to see some sunspots in SkyTour LiveStream, because we do have a solar telescope as well.
Oh, cool.
Yeah, I was thinking of giving that a mount too, but can't do everything in one observatory, But it might be pretty cool.
Says who? If you want a dedicated solar telescope, maybe you have to build another observatory next door to the one.
Oh.
That's an idea.
Well, there's certainly room out there.
Yeah.
Yeah. Solar telescopes
go for an H alpha scope.
That's what I got.
Oh, really?
Yeah, it's one of the Coronados.
Oh.
Yeah. It's a smaller, it's only the personal solar telescope, the PST. Yeah.
That's not too bad. Some of the, I didn't want to get too much into it because it may be beyond the scope of this talk, but...
Scope.
Solar optics can get real expensive when you're looking at high quality H alpha stuff.
Yes.
I mean, the Coronado PST, I think it's called, is probably about the cheapest one out there.
That's right. I think it is the cheapest one out there.
It's what is that, like a 50 millimeter or 60 millimeter or something?
Yeah, it's small. You don't need a lot of aperture, to see the prominences on the sun. You know, the gas is leaving off the edge. You
Right.
don't need a lot of aperture to see those. You know, but you do need a lot of aperture if you want to see things like granules, and you want finer resolution. You know.
Yeah.
Which kind of goes against it, because you say, well, the sun's so bright, why do you need aperture? People usually stop it down. Well, it's a matter of seeing detail. And you can't see a detail through a pencil. You gotta, see a detail through something bigger.
Yep. Dollar's limit.
Yeah. Hey, Kyle Lynch is here. What's up, Kyle? There's Mars. And I think that we shall just check it out and see what we can do. All right, now let us to play. So what I'll do is I will take down over here. You'll notice in this side I'm taking down the ISO, the sensitivity, and we're going down to 50, which is the lowest this camera can go. Actually, it should be able to go. I wish it could go to 25, but it can't. And then 25 seconds will take down to a fraction of a second. And when you start to see the color of Mars right there, we'll drop it down one more or two and take a photo here. Let's see. Now it's a little tiny dot, right? Wow. I'll make sure that that's not artifacts, but I think it might be. I have to check that out.
I was looking for that. I've evidently lost my link to that NASA planetary images, that planetary viewer page.
Really?
It'll show Mars, what's facing us in real time.
Yeah.
I can't seem to find it. I know I looked at it the other day, and what I had talked about earlier, we were seeing like Sirius Major every night, and it was slowly shifting from east to west across the sky.
Yeah.
Sirius Major is clean out of the picture now, and there's all new stuff up at this time of night facing us.
Yeah.
See if I can find it.
No, we're still getting some detail. It might need some focus assistance here. So I'm going to take us to a nearby star and see if we can focus. We can try that. Well, I'll do it this way. So I'm going to change the ISO. Okay. 500 for 3.2 seconds. We can take a picture and then do an examination of the stars. There's a lot of ways to get focus, and I still need to do some of that. Doesn't look bad.
Well, darn it. It appears to be gone.
You know the name of the service? That we can look it up by the service name?
It was something or other JPL, and I don't remember what it is offhand. I'd have to go look it up again. I don't know where it went, because it should be in my favorites, but it doesn't appear to be there. NGC 4565.
Where'd you see that?
Came up on your screen for a second.
Did?
Yeah.
Serious?
Yep.
Where was I?
I don't know.
Maybe it was over here.
It took up the whole Skype image, though. The whole Skype page.
Okay. Well, I don't... That's odd. Okay, well, I'm not sure. Anyway, so what does this programs say Mars is supposed to look like now. Let's try that. All right, let's see. Oh, look at that. That's what Mars should be looking like to us. We should be able to see the South Pole cap.
Golly, is it?
Whoops.
I wonder if your time is still right. That's Syrtis Major on the right, and that's Sinus Sabaeus above center. Hellas is the light spot below lower right of center.
Yeah.
And Terra Meridiani there attached to Sinus Sabaeus at upper left. The whole Terra Meridiani and Sinus Sabaeus is that club-like thing above center.
This.
Yes.
Yeah. So, I mean, if the time wasn't right, the telescope would not be working. So let's find out what's going on here.
Yeah. I sent you that link recently. It was something or other at JPL. You don't have that?
If it's in our chat, it's still there. Time's right. Time is right. Let's make sure the location is Wolcott, Connecticut, which is it's about 10 miles from here, but it's still accurate enough.
I know. I looked at that some days ago, and Syrtis Major was clean off the left-hand edge of the planet now, and a whole different stuff had come up. I was thinking maybe you could see Valles Marineris now, if anything.
But at what time are you looking?
I was setting it for, I forget. It's expressed in universal time, so I was looking what would be evening for me, or like 3 o'clock in the morning, universal time.
Okay.
Greenwich Mean Time, in other words.
Okay.
Give me just a minute. I'm
No
going to go
worries.
back.
I'm going to try and take a longer exposure here to pick up the moons if I can. So how's everybody doing tonight? Anahata 77. Hey there, Bonnie. How are you? Nice to see you. It's always good to see you. Well,
There it is.
You found it?
Yeah, I've been. Yes, I found it.
Okay.
It's on an older set of favorites that I saved to.
Okay.
Give me just a couple minutes.
Sure.
Here.
And also drop that link in our chat together so I can use that later on and
I will.
bring it up and show folks too.
Let's see. Yeah, I'll call it 3 a.m. Run simulator. Well, no. Kiss my grits. It corresponds really closely to what Stellarium is showing.
Okay.
Syrtis Major has come all the way back around where it's over on the right-hand side now, and then Terra Meridiani and Sinus Sabaeus are just above center, and Hellas Basin is to the lower right.
Okay.
Yeah, let me go back and...
Well, folks, you've seen it here first. Mars blowing bubbles. You actually can see, it's kind of interesting. I'm wondering what these vertical line artifacts might actually be. I mean, clearly the donuts are the telescope optics, and I've taken a long exposure, so we get lens flares and things. It's kind of cool. But I was looking in particular to see where the moons were. We have Phobos and we have Deimos, lower right and upper left, and I probably didn't go long enough. Probably didn't go long enough to show them. But if I go any longer, we're just going to have all kinds of abstract designs. So I guess we'll just forego that. Now, in the real world, what you do is you use an occluding disk, which allows you to block out the brightness of the planet, but take pictures around it so you can see the moons in more detail. But that is a higher-end piece of equipment that you'd find in a large observatory somewhere that's government-funded, you know. Not in a little observatory like ours that isn't government-funded. I'll tell you, if any of you out there know any foundations that want to have a pair of observatory sites at their disposal to bring astronomy to the masses. We are all about educational outreach, and I really think this is really the way to go. I mean, especially with COVID and everything right now, right? I mean, Mars is so bright, it's making my face glow. Look at that, Daryl. I mean, it's really bright. You know?
Sure is. You're getting a Mars tan.
I'm getting a Mars tan, yeah.
Yeah.
Yeah. Oh well, that's okay. I don't mind. So yeah, so what we'll do now is we will pull out of here, and we'll take another couple shots of Mars to see if we can capture any details. Did you really say kiss my grits?
I did. Who said that?
Well, kiss my grits.
Yeah, it was the show. I can't think of their name.
Beverly Hillbillies?
No. It was waitresses at a diner.
Oh, not what's her name? Rhoda Morgenstern? No.
That sounds sort of familiar. Rhoda was she a friend of Mary Tyler Moore's?
I think that was the way that they set it up.
The one who said "kiss my grits" was another waitress, so they might have called her Flo. She's a big old.
Oh yeah, I remember Flo.
Yeah, she was tall, blonde, southern.
Yeah.
She'd say,
Well, kiss my grits.
Kiss my grits.
Yeah. Yeah.
Anyway.
Well, we can see Syrtis Major here, and we can see a hint of Sinus Sabaeus up here, and Hellas Brightness down here. We can kind of see that, no?
Kinda.
Yeah. Yeah. Let's see what the seeing is like, you know.
Alice! Tara got it.
Oh, thanks, Tara. That's right. Alice. And Mel, wasn't Mel the boss?
I think so.
Yes. He was that. I forget his name. Oh, wait, I do know his name. I kind of know his name.
That big bald-headed guy?
Yeah. Talk like this. He played Bella Oxmix in a Star Trek episode.
Yeah. Wow, you're good. I didn't realize that was the same guy. You're absolutely right, though.
Yeah.
Yeah, the gangster planet.
Yeah. If you ever saw a Star Trek episode, guys, where it's actually called A Piece of the Action, and the crew of the Enterprise goes to a planet, and it's like they've landed in like 1920s Chicago.
Yeah.
There's gunfights going on. There's gang hits. The mob is active, and they find out that a previous expedition, again, the Prime Directive being violated, a previous expedition had a book they brought to them, and it was called like Mobsters and Gangsters of 1920 Chicago. And these people took it to heart like it was their religious doctrine, and they turned their entire world into the old Chicago, you know. And it was just funny, and it was called A Piece of the Action.
Yeah, it was one of the sillier Star Trek episodes, but it was a fun one.
It was. Hey, Scotty, do you think you could put on some heaters and, sprinkle a little, knock down a few guys in our location? What, sir? Train the phasers on the main street outside and shoot a burst. Oh, I sir. And then, of course, he does, and they all fall down. Hey, that's impressive there, Koik. It was pretty funny. I'm getting some of the dialogue wrong, of course. But yeah, look at how Mars is dancing here. I got it on the higher focusing view. You can see it dancing next to the point of the arrow. You can tell how the sky is just a little bit rough there. Hey there, Adam Larber. How you doing? Or Adam Larber, sorry. Oh yeah, the Martian Chronicles, based on Bradbury, absolutely. That was phenomenal. It's all good.
You know, I read Ray Bradbury a long time ago. The Illustrated Man and the Martian Chronicles were popular back in the 70s, I guess. And, he was a good writer, but he was not good at science fiction. He didn't really understand science. That probably sounds like heresy to a lot of people, but that's what I thought when I read it.
Well, Stanley Kubrick didn't either. Stanley Kubrick didn't understand science, but 2001's a classic.
Well, that's why he hired Arthur C. Clarke.
That's right. That's right.
Now, there was one story, again, it was either Illustrated Man or Martian Chronicles. It must have been Illustrated Man, I think. Some mother and her son spent all their waking hours at night. They slept through the daytime. And Mom, in particular, could not stand the sight of the sun. And it turned out it was because her husband, the boy's father, had died on a spaceship that fell into the sun.
Wow.
Falling into the sun is about the hardest thing to do in the entire solar system.
Yeah, it is.
I assume you know why.
Well, there's no falling into the sun. You can't fall into the sun.
Well, you'd have to scrub all velocity relative to the sun. You know, we're going around the Earth's orbital velocity around the sun is like, what, 67,000 miles an hour or something like that?
You gotta get rid of all that to be able to fall into the sun.
Yep.
You could only spiral in over a slow period of time.
Yeah.
Donald Kunzer, hello, welcome. Yeah. Okay, we're gonna skip away from Mars here now, Daryl.
I don't blame you. Thank you for indulging me.
Not a problem. Not a problem. I want you to also enjoy your time at SkyTour LiveStream. You're allowed, you know. So let's find out what else now. What was that galaxy you said we wanted to see?
Well, there are two. One is NGC 253. I believe it's in Sculptor. And then M77 in Cetus. There's Cetus, just that's Menkar there to the right of Mars, to the left of Mars.
Yeah.
And it's close to Menkar. That's the head of the whale, and it's not far from Menkar. A little bit over to the side.
Yeah, I'm trying to find it. Should be able to see it. Oh, wait a minute. No, I do have them. Is it Cetus A? That's M77.
I'm sorry, that says M7. Yeah, okay.
That's M77. Let's try that.
All right.
Okay, let's go see.
It's a nice kind of a space-on spiral galaxy, as I remember correctly.
Yeah.
We looked at it last year about this time.
Okay. The telescope might not be able to... I gotta bring up the exposures here a little bit so we can see what it sees. Okay. Alright, there we go. Now, for those who joined us late, I showed some photos earlier, which I won't do again, but we have been experimenting with a technique that seems to be paying off great dividends. And that is a technique by which we can photograph at a very high ISO. In other words, make the camera be so sensitive that normally we get a lot of noise in the image, and noise is something you don't want. But if we can do it, we need to be able to have a way to get rid of the noise, and that's kind of what this other technique was for. And I think I've perfected it. And so some of the things that we've taken pictures of are just spectacular, which include objects, taken at very high sensitivities, like this one. Okay, this is the one I showed earlier. This is the Elephant's Trunk Nebula. I took this last night at 102,000 ISO, and then I used a special system that we got from Topaz Labs to use artificial intelligence to get rid of the noise. It's amazing. The difference is night and day. And you know how Daryl is. Daryl's very, calm and collected, but when he saw these images, he was like, wow. And he's also looks at it and says, this is the new way of things.
Oh yeah. Oh, it's quantum leap.
It is. I'm going to do 20 seconds at 40,000 right now. I think the telescope might have had some trouble getting to the galaxy, but if it looks red, I'll have to go move the dome. Because I have a red light on inside the dome, and we'll see if we're catching an edge of the dome.
I was wondering, looking at your dome cam image here.
Yeah.
Looks like it might be in blue.
Could be very... Yeah, see? Yeah.
Yeah.
Yeah, there it is. So, but there's the galaxy. Right there. We got the galaxy. Okay. I will be right back. I will show you the Mars donuts while we wait. I'll be right back. I'm going to go move the dome.
Okay.
Enjoy the music. Enjoy the interview.
Hello, Vera Lucia Campos.
I'll be back.
Anybody I missed earlier, howdy everybody. The weather sucks here. We had the most wonderful run of 70s weather through October, with the exception of a couple of early snows. We just had beautiful weather every day, and here Saturday it started turning. It did get up to the 50s, I think, yesterday. But it is down in the 30s all day today, and it's snowing like crazy up in the high country, I believe. And they were saying a chance for snow here, but it never did that I saw. It was just cold and gray and windy. I'm afraid winter's upon us, and winter's still a month and a half away officially. Welcome back.
It is I, Arthur, King of the Britons. Why didn't I vote for you?
Sorry.
That's right.
I just noticed your new headset. I think you mentioned that the other day.
Oh, it's not even a headset. It's just earbuds.
Earbuds, yeah.
It's better than the large headphones, and the large headphones are just ponderous, and this actually works better. And I can hear other things. I'm not, not stuck with it. Okay, let's go back and image Cetus A. But first, knowing that it's right about here, let's bring it up more. First things first, let's do this. Okay, that should put it right about here. To confirm that, I guess we could actually just go full on mode here with the okay, I think might be here. I don't know. I'll have to see. Let's go see. Let's go see. And we'll drop this down. About 40,000 again. Do 20 seconds. Little finder frame. Now, after we find an object with the telescope, we have to wait for a little while. 11 seconds is a little while. And the telescope can then lock on to our target. So it's good. And it is a small world, Catherine, I mean. Oh, look at that, Daryl. That's
There you go.
That's Cetus A. It looks really pretty. Wow. Look at that, guys. There we are. And now we can experiment with the settings here. But, you know, you can see when you look here in the galaxy, right? It's got a beautiful spiral structure that you can see. It's very tightly wound, right? And that tightly wound spiral structure is something that's you know, systemic to these kinds of galaxies. These are very, very compact galaxies, and so we don't really know much about their prospects for planets compared to, say, ours. But we do know that there's probably 2 trillion galaxies out there in addition to our own, right? And galaxies like this could harbor life, and we shouldn't look at them as anything other than potential islands of life. I do. Daryl may. I think it's just important. I'm going to drop this 40,000 down a bit here. Let me take us back to our view that makes sense to you. And we'll come down. What?
I'm sorry, I've got too much going on. Daryl may what?
No, I was saying, okay. I was saying that you might agree that there could be life in that galaxy.
Sure.
Yeah. And most astronomers do. I'm not opening a beer, I'm opening a V8, just so you know. Okay, I need my vegetables.
Well, as somebody once said, you know, with all the stars and galaxies and all the wonderful things in the universe, it should be a waste if there wasn't anybody else out there.
Yeah. And Seth Shostak said something like, if, how do you say it? I'm trying to remember. I'll remember the quote. It has to do with finding life. All right, 12,820 seconds. Let's go to 25 seconds. Something like, if there's life in the galaxy or in the universe other than on Earth, that'd be amazing. But if there was no life in the universe other than us, that'd be a miracle. So.
Very nice.
Look at that. Oh, it's a beautiful galaxy. Yeah, you can see it has some dark lanes in there. I'd have to look at Cetus A from the Hubble Space Telescope to see what the actual structure is in there. But Cetus A is a galaxy that's, let's see where we are. Cetus A is, I'm going to get the distance. It's 46 million light years, actually 47 million light years away. That's pretty far, you know, compared to the Andromeda galaxy, which is only 2 million light years away only. Okay, but you're seeing this galaxy here in this image. You're seeing this galaxy as it was 47 million years ago. So shortly after the last extinction event on the Earth, the light from that galaxy left the galaxy to come here. Just a few, obviously 20 million years, but we're still talking, a substantial 18 million years. So, but still, think about that. That's how big this universe is. And the light that we're seeing right now hitting our eyes started off on from that galaxy 47 million years ago. That is amazing.
I am looking at a Hubble image of M77. It's in the M77 Galaxy Wikipedia article. Sort of reminiscent of M33 almost. It has a lot of H2 regions in it. Great big ones.
Well, then, what we could do, and I've done this before, is by zooming in here, I can see some areas right here. Is there one like at this part of the galaxy? And one over here?
Yeah.
Okay, so it looks like one up here as well, and might be something there. But I do see a very large region here, and it's actually the most. This is pretty prominent too. It's actually kind of red in this image as well. So it looks like there's H2 regions all throughout here, actually.
Yeah.
Is that true?
Yeah. Got to go back and forth here.
I know.
The orientation is slightly different in the images they have, but there's a great big one over on the right-hand side.
Oh.
Reminiscent of the really big one in M33.
Yeah.
That one we see over to
That's
at
up
the
on
upper
the top
left of
left,
M33, and several others.
Wow.
And there are diffuse. You might see it as a halo in your image. The central part of the galaxy is pretty tightly wound, and then there's outer stars in it too. Kind of a halo around it. You can see that on the image.
Yeah, this galaxy is kind of odd because it has sort of a Cassini's division in the galaxy, doesn't it? Of a gap between the outer area in the galaxy. It's pretty cool. I'm gonna try something here. We're gonna drop this down to say 8,000, and we're gonna drop this up. We're gonna go to 1 minute. Yeah, let's see if we can get a shot that is lower noise but higher detail that might show us some of those H2 regions. When we say H2 regions, folks, when you want to know what that is, it's a pen name. It's a sort of a kind of a moniker, a name that we call these regions in space where the hydrogen gas is glowing red. And we call it H2 because it's Roman numeral 2. It's not the number 2. It's H Roman numeral 2. And it stands for ionized hydrogen. And singly ionized hydrogen, because ionized hydrogen only can be ionized one time. There's one electron, and when it leaves the atom, it's ionized. It doesn't have any more electrons to ionize. So it's always singly ionized hydrogen. But what does that mean? Singly, look at that. Wow. Singly, that's pretty.
Yeah. I just posted a link to the Hubble image as shown at Wikipedia. And what they show is a great big H2 region over at about 3 o'clock. Your orientation is slightly different.
I see.
It's at about 4 o'clock here.
Yep.
On your image, and then another big broad band out toward the top, and
yeah, I see
several all around the galaxy.
Wow, that is pretty cool. Yeah, it's beautiful. Yeah, so let's let me see. There's got to be a way to show folks this. I gotta try and get this in here for you guys. Hang on. Will that do it? Yeah. Okay, just a minute. I thought I might have had this up. Let me just minimize that. Hello, STLS. There we go. This is the galaxy that we're talking about right here. I thought I had that. I thought I had that available to us. Let's see.
Can you slide that to the left side?
I can. I'm just trying to make sure I grab it. Here we go. It's here. There we go. Okay. So, let's do a little additional move. There we are.
Yeah, that one there at 3 o'clock, that's at about 4 o'clock in your image, I think.
Okay, I think you're right. Let's go take a look again. And here's our image. And let's check out. We zoom in. We still have some noise, but what Daryl's talking about is right here. We can see it on this image, all right? And then we look at the Hubble image of it, which apparently is not there anymore. Where'd it go? Oh, should have been there. Oh, come on. Oh, I think I know what happened. Just a second. Okay, here we go. Okay, so there you go. So we see it here, right? And when we look at our image, okay, it's right here. So this is kind of canted at an angle, and in the photo we looked at, it's like this. Okay, but look at that, huh? That's really beautiful. It's very tightly wound in the center, and it spreads out on the outside. With the proper photo session, I could coax a lot of detail out of this. This is a very nice find. Well, very nice galaxy, yeah. Yeah, so check that out, guys, if you want it, and then you could download that image too as well, because the Hubble images are always available to anybody, and it's really pretty. Every red spot you see, every one of those red spots, those are star-forming regions, right, in these galaxies. And these areas here, like this, okay, I'd have to check to make sure that's in this galaxy and not some other object in the foreground, but I think this is in the galaxy. These might be large associations of hot O and B type stars called, needless to say, OB associations. Pretty cool. Very neat. Very, very cool. So, that's a beautiful object that you had us look at. I'm going to try a couple other things here. Let's actually drop down the settings dramatically. Let's go to 2000 ISO and do a 1 minute at 2000. This may not prove fruitful, but let's find out. This proves veggie-ful anyway. This beautiful V8 here, which you can't see. I don't know why. There we are. See? It looks backwards to you though because I reversed my camera.
All you need now is a little vodka and some Worcestershire sauce and a celery stalk, and you'd have a Bloody Mary.
Well, I guess so. Yeah. I'm not a drinking guy. What can I say? I've never been in that world. I don't know what it's like. You know?
Further opponent saith not.
Yeah.
Party till you puke, you know?
Yeah. Okay, so we got this, we got that, that's there, and okay, now we're back to that. Okay. Just getting some things back that were lost. Let's see now. Okay, that is image that wasn't too good. We had an issue there. We'll do it again. But we can see that the image got blurred, but this ISO setting, or speed, as it was known traditionally, might be better once we get a clear shot. No, actually, this one is blurred too. Look at those 2 dots. Those are not really there. That's actually... Well, wait a minute. That just might be noise. I think that's noise because the stars are round. So, that's noise. That's alright. Not bad, though. And this isn't enough to capture. We'd have to do longer, deeper shots. Do the high ISO thing and then use the AI system to remove the noise.
Right. Well, something for the to-do list.
Yeah. It's pretty, though. Pretty pretty. What was the other one you wanted to see?
NGC 253. It's in Sculptor. It's probably back under Aquarius. You probably have to move the dome again.
Oh, really?
So I leave it to you if you want to mess with that. But it is a great big galaxy. It's actually pretty comparable to M31 in Andromeda, size-wise up in the sky. I think they call it the Silver Dollar Galaxy, if I remember correctly.
Silver Needle?
Nope. I think it's Silver Dollar.
Huh.
I could be wrong. I'd have to look it up.
Alright, well... I do not know. Okay.
Indulge yourself, Mr. Sulu.
Yeah, that's right. Oh, shoot. I wonder what's going on. Why is it doing this? My system did exactly what it did before again. It ended up... Oh, I know what's happening. I'm hitting the wrong key. I was wondering why I couldn't see anything. It was racing ahead again. You know? It was racing ahead. That is to say, Stellarium was racing ahead. Alright.
There's Difta,
Yeah.
also known as Deneb. That's the tail of the whale.
The silver coin you're talking about.
Silver coin, maybe that's it.
That's it, right there.
Yep, that's it. Right under Difta.
Yep. Alright. Let's see now. That is... in relation to Mars. Well, I don't know. We might be able to catch this. Well, then again, wait a minute now. I'm not... I actually moved over substantially. Yeah. I think that would put us... Yeah, see, we're already looking toward the west, and the dome is heading more toward the east.
Yeah. Well, that's alright.
Okay. Next time we shall do it.
No problem.
I do want to take a look, though, at the Pleiades. And those are right over here. And I want to show the nebula around Maya.
Would you excuse me for a moment, Mark?
Sure.
Be right back.
Alrighty. Okay, while he's going, let's all hide. He comes back and there's nobody here. Okay, so now what's happening is the telescope is centering up on a star that it's going to pick as the high-tech centering star, and then we bring the Pleiades in here. And that is the Pleiades right there. Now, you can't see the shape of the Pleiades because the telescope is, of course, higher power. And it's sort of zoomed in. But we can catch them. Alright? Now let me, let's just do a run to the east here. Actually change the speed. Run to the east, run to the south. Okay. This is the star Alcyone. Okay, in the Pleiades. And to see it better, let's bring it up. Alright. And I will take the observatory view and just hide it for a little bit. And now what we'll look at is we look at the Pleiades here. Okay, this is Alcyone right here. Okay, Alcyone right here. Right, and we look down here. We look at Merope, which is here. And you see the stars in the Pleiades. Now, if you don't recognize the shape, it's 1, 2, 3, 4, basically, and then this one atlas out here. Okay, so basically, it's. Let me move this up a bit to give it back to you. We want to see it. That's more like it. Okay, now you can actually see it a little clearer. Oops. Well, if I would go the right way, you could. Okay. So there you see it. 1, 2, 3, 4. Okay, and then Atlas is down here behind my head. Okay, so this is the main stars, and what we'll do is we're going to do something absolutely crazy. We're going to do 30 seconds at a fairly high ISO. Why am I doing that? I'm going to do it at 51,200. I want to capture some of the nebula that you see around these stars. The Pleiades are well known for that. Okay, so 30 seconds at this setting, and here we go. We're off and running. I'm so excited. I'm so excited. It's nice to have you all here tonight. Thank you for coming. This is the last stream, I think, before our Arizona Observatory opens. So tomorrow I have to go to New York and start filming for Travel Channel. It's a 2-hour documentary, and it should be the lead-in to something of far more enjoyment and for all of you. We'll see. Okay, that's beautiful. It actually worked very well. Here you can see, in fact, it's right down here. You actually see the Merope Nebula. This is sort of like it looks like a brushed blue, hair right there. And that's systemic to this nebula. These stars were not born in this nebula. This nebula is just scattered light. It's dust in interstellar space that these stars as a group are moving through. And that's what's causing this to glow. Now, if you look, if we look up here, okay, here is the Merope Nebula. I'm sorry, the Mayan Nebula, okay? This is one that's actually, it has this little finger on it, and I know you can't really see, so I'm going to move it down a little bit, okay? And there it is right there. You can see it right there. And it looks really pretty. It's got that beautiful, here, come here, Merope. Let me grab you. Let me grab that star. All right. And now you can see it's really beautiful. You see this little arc. All right. And that arc, again, is dust that is actually being illuminated by the stars. These stars are B-type stars. They're hot and blue, and they are young, all of which will probably end in supernovae. Gosh, I would love to see that. They're several hundred light years away, though, so they won't hurt us. Okay, rock stars in the house. Good to see you, Rock. So I think that this is a really cool place in the night sky. It would be great to actually spend some time visiting there. I'd love to go there, but we wouldn't survive there because it's really hot. Okay, very hot. So, that said, let's take a little different approach. Let's try going south for a minute and pull in that star. Y. That's better. Alright, let's do it this way. Okay. Now you see what I'm doing. Okay, so now we're going to pull in this star here. This is Alcyone here. This is Merope. Alright, and we're going to do 1 minute at 40,000 ISO. Hey, Daryl, welcome back.
Thank you.
And did you see the image of the Pleiades I took just a moment ago?
Yeah, for just a second I did.
Okay. No, here you go.
Yeah.
Yep. And
Subaru.
yeah, Subaru. Yeah, that's right. Notice on the Subaru cars, on the hood ornament is the Pleiades.
This is true.
Yeah,
I don't
and
think we ever mentioned that before, have we?
I think we have, yeah.
Okay.
I have. And it really means unity. So it implies, unifying under one brand or something. It's a lofty statement about the Subaru. Pretty cool. Vera Lucia Campos, how are you? Welcome. Thank you for coming in. Yeah, you couldn't live there at all, Vera. That's for sure. Oh, Tara said that. Sorry. Oh yeah, look at that. Now you can see this beautiful brushed look to this nebula that Daryl's called it. Like it looks like it's brushed, like it's hair almost.
Uh-huh.
And that's the filamentary nature of this stuff. It scatters the starlight, and because it doesn't scatter all the light, it only scatters a certain frequency. It actually looks like it's a blue nebula, when in fact, even if the star was white, it would make blue color, all right, because of the fact that blue is in the spectrum, but it's the blue light within the starlight that would get scattered by the dust particles that are causing this. It's dust which is causing this. So technically we call these reflection nebulae, but they're not really reflections. They're scattering nebulas. But, to talk about Rayleigh scattering with every single person you meet is ponderous. So they call them reflection nebulae, but it's not just a straightforward starlight reflecting off dust. Yes, that does happen too. But it's more of the selective absorption and re-emission of the blue light, the scattering process. Think of it, the light is getting shunted to one side in every direction. Well, that's pretty. All right, now let's go take a look at Maya. So we're going to head north a little bit until we see Maya, and then we'll look at the Maya Nebula. I see Maya. That's Maya star. Huh?
Don't they say now that the Pleiades are just passing through that the dust clouds there?
Yeah, when you were away, I mentioned that actually.
Oh, okay.
Yeah, no, but you're right. And the Pleiades, these stars are beautiful stars, but as Tara mentions, great place to visit, but you don't want to live there. Okay. Actually, I'm not even so sure it'd be a great place to visit. You would need some really high-end radiation shielding, and you wouldn't be able to go to the window and look at it. That would be the last thing you ever did. It would blind you, and probably from the neck up, you'd look like burnt bacon. And I think that wouldn't be too exciting. You'd be like Leatherface for real. Yeah. So, hey there, Brian Levitt. How you doing? So we're taking 1 minute here at 40,000, and our previous shot at 40,000 brought us the Merope region, looking like this. You can see the blue glow everywhere. Okay, there's blue nebulous detail everywhere because the starlight is being scattered, you know. Now we'll see the Maya Nebula in a moment when this 1 minute is done. Oh wow, look at that. Look at that. It's really beautiful. Now, what's interesting, guys, is that in some of the Google images of the universe, okay, people see stuff like this over here, and they say, that's evidence of extraterrestrial life, or look, a UFO captured, you know. But in fact, it's actually just a lens flare. Now, if we were to make, if we were to take, for instance, and make a mosaic of this, all right, and we made a mosaic of all these, then we might miss this one, and it might make it into the final version. And you'd see the overall Pleiades and then this weird thing that didn't seem to make sense. And the reason it makes sense here is because it's from a star just outside the view that's causing this brightness. But when you put it all together, okay, it might not be that clear to you. It is to us in astronomy, but I have to go back to this Maya Nebula here. Look at these beautiful little details in here. I don't ever think I've seen those before, Daryl. This is just kind of new, you know?
The dark bands?
Yeah. I don't think I've ever seen that. All I've ever seen is this part. This is neat. You know? I've seen, like, we've come here before, and I've seen this part, you know, I've seen this arc, all right? Let me get over to the arc. Yeah. I've seen the arc right here, but I've never seen these dark bands in here, and this stuff that's in here. This is really kind of cool. I like that. Yeah. Yes, folks, I jump around the screen sometimes. You have to pardon me. I just, like, you know, oh, knock me way up there, and push me down, and pull me down. There we go. Okay. So yeah, that's beautiful. Pleiades, an immutable object of such beauty. I'm thinking of getting a telecompressor for this telescope. It would actually give us a wider angle view. And there's telecompressors specifically made for these, what are called anti-coma scopes, which is what this is, ACF. And there's a telecompressor we can use to get a wider angle view without compromising and losing the edge of the field into like blurry streaks. And that's what we call coma. So that's neat. That might happen. I'm not sure yet. It won't happen this trip. I've never seen Hind's Variable Nebula, have you?
I thought we looked at that before.
That's Hubble's
I think I've said that before, and I was thinking of not Hind's Variable Nebula, but the one over in
Hubble?
Over in
Monoceros?
Yes, Monoceros. Thank you.
Yeah. That's Hubble.
I think we've had this conversation before.
Okay. Yeah, that's Hubble's Variable Nebula. But you know what?
Yes.
I am going to see if we can see Hind's Variable Nebula.
Isn't Hind's Variable Nebula a recent discovery, or am I thinking of something else again?
I do not know. It's an H2 region, but it's only magnitude 6.5. I'm not sure how big it is, but we'll find out. Okay, we're pulling in now. The star just kind of rolled into view here as our spacecraft is pulling into Heinz Variable Nebula orbit?
No, I must have been thinking of something else. Discovered in 1852 by John Russell Hind.
Yeah. Okay. Not bad. We shall do our best to do it justice. I don't know what to expect here. I guess I should just take the picture. Okay, picture underway. Sure. Back to the Pleiades. See, winter's coming here, so these hot blue stars feels good, you know. You know, it's just excellent. Hey there, Bobby Burgess. How you doing? If any of you guys have any questions, feel free to ask. Oh, thank you, Catherine. I will have fun. It's going to be 13 days of filming. It's a pilot, and hopefully... looks like we have some dome in the way here. Yeah, you know what? That's okay, because I knew I wanted to move the dome anyway, because we have one of the more beautiful constellations is up now, and we'll be able to maybe see just a little bit more in it here. That's kind of why I started at 9 p.m., just to give us the opportunity to see it. But I'll be right back, okay, Daryl?
Okay.
All right.
So, how's everybody doing tonight? Sorry, I'm spacing out here. Mark's chat isn't up to date, as seen on the Skype page, and I happen to go to the YouTube page, and Adam Lorber, where do I live? I live in Colorado. Specifically, I live in Colorado Springs. Thank you, Tara. Carol. I was saying earlier, the weather, the skies have crapped out here recently, but when it's good here, it's really good. We get marvelously transparent skies. The seeing isn't that hot a lot of the time because prevailing winds come out of the west or the west-northwest, out of the mountains, and that disturbs the air. So we get pretty turbulent air over town here, which isn't great for high power viewing, but it is good for low power wide field viewing. It's one reason I like looking at low power. And you have to get way out on the plains to get away from it. Go out an hour or two east of town to get away from the turbulent seeing. And Mark is back. Welcome back.
Thank you. I am here. All right. Okay, the first thing we're going to go look at is this guy.
Going to look at Heinz Variable Nebula first?
No, I moved the dome.
Oh.
Yeah.
Okay.
Yeah.
Mark, could you update your chat in Skype?
Oh, sorry.
Brian, the fires are much better contained and the weather has helped quite a bit. I think they are still burning, but containment is a higher percentage now. We're not getting the smoke like we were.
Yeah, that's the reason we put metal skin on the observatory, was because even in the desert, brush fires can burn hundreds of thousands of acres like nothing. And they do. You know, when I was there, Marianne was actually with me. We were going to Marianne Robb, of course, who went to bed. But she was taking me up to Sedona to do a talk. And when I was up there, on the way, we crossed the highway, and on both sides of the road was fire. And it was like you were going through a moonscape for a period of time where there was nothing. It was destroyed. So, and there was low scrub, you know, so, you know, it's, I don't know. It's pretty amazing, you know, to see how nature handles things like that. Okay, I'm gonna do 30 seconds here, not for that. Okay, we'll do it for 40,000. I'll do 32. Okay, and away we go. And this will be the rubber stamp nebula, as we call it. It's small, but it has a really interesting look. It's kind of an exotic looking nebula, and I think it's really cool. So I'll show it to you. And I think you will enjoy it. Because we talked about the elephant trunk. And this one is not like the elephant's trunk in that regard. Come on, don't tell me I got a dome already. How can I have a dome in here? But there's the rubber stamp right there. It has this little black area right there, which is just so cool. It's sort of like it's a dark nebula, which is dark dust, not gas, because gas can't be dark. And this dark dust is blocking the light of the nebula behind it. See? And so that's what's going on there. So that's pretty cool.
See that?
I'm not liking the fact that I guess the dome is still in the way. I'm gonna have to go move it again. All right, let me just bring this up before I do that. Now let's do. Hey Don D, how's it going? It's really good to see you. Thanks for dropping by and saying hi. Hang out with us for a while. Okay, 3,200, 2,500, 3,200. And 30 seconds on the nebula, which is now going to be right about here. Which, let me show you where that is. It's going to be right about here. Right about there. Alright, we'll go back to our other view. It might still be a little red, so I'm going to have to move the dome again. I thought I covered it. I thought I took care of that. Apparently not. Well, there it is.
That looks better.
It does. Well, we don't. You're right. But you see there's a little red here. I'll have to move the dome again. But look at that. So there's a central star, and they've got this dark dust mass that just seems to be sitting out here. And the bright nebula behind it is silhouetting this black thing. That's how you read these things in the interstellar medium. At least, because the alternative is to think, oh look, there's a hole in this glow, and that's actually kind of rare. Kind of rare.
Do they call it the rubber stamp just from the shape of it? Or?
I wish I knew. This is again, our one of the things, guys, our program that we like to use is called Stellarium. Stellarium controls the telescope as well, if we let it, and sometimes we don't like to let it. But what's neat is the Stellarium product, has all these things. It's also called the 13th Pearl Nebula, which I have no idea what that means. The one I've grown up with is the Black Eye Nebula. I've heard about that. I've heard that. Okay. We also have the Black Eye Galaxy. So this is the Black Eye Nebula. And so that I've heard. But it's NGC 1999. And NGC stands for New General Catalog. Alright? And we are in Orion. So you'll probably want to say, come on, show us the Orion Nebula. Okay, I will. Jeez. So let's see if we can find it without having to go through the coordinates. Let's head north. Actually, let's change the speed of our motion to make that go faster. Oh, something's happening. The stars are falling. And we end up going here.
Ta-da.
Ta-da indeed. Ta-da indeed, Toto. And let's focus this while we're here, because this gives us a focus opportunity. This is my huge arrow right here. And what I'm going to do now is bring the whole telescope west until this object slides into view. Okay, you can see that the sky is a little turbulent. Alright, but let's focus now. And you'll notice that they will either get another farther out of focus, so we go the other way. And then once we cross through that threshold and come back. Okay. So I believe that we now have some pretty good focus here. Alright, so what do we do now? Well, we take pictures now of this amazing location in space. This is a beautiful nebula. And for those of you that haven't seen this, I think you guys really need to see this. So don't go away. Don't go make that sandwich. Just hang out 1 second. We'll do 30 seconds at 3200, okay? So there we go. And then we'll come back to here. That's our rubber stamp nebula, or the 13th Pearl, or the Black Eye Nebula. Okay, and now get ready for the Great Nebula in Orion. It is the quintessentially the most beautiful nebula on the planet, other than the Eta Carina Nebula. And for the Northern Hemisphere, this is the most beautiful nebula. What do you think? Am I right? Come on, you can do it. It's beautiful. Okay, and we need to take another picture because 30 seconds, it kind of walked a little. I'm actually going to go to 4,000. Go up another stop. Makes everything a little brighter. Yeah, and this is our regular view. And then this will be our view, and you'll see it come in. Well, Ronald ERRT Radio asks, how many stars are connected with that nebula? Well, this particular nebula is known, and many like this are called stellar nurseries. And for the very reason that they are the locations where stars are born. And so, stellar nurseries, thusly. And so there's many places inside the Orion Nebula where we think we see stars in formation. Okay, we also see stars that are in a turbulent early age of their lives called T-Tauri stars. We see stars that are in the nebula that are actually not part of the nebula but are foreground objects here. But so you got to think of the nebula as a blister on a large dark patch. Okay, so let's see if this one was better. Yeah, this is better. Okay, this is dark nebula in here, and this dark nebula that you see, this is part of a much larger dark area. This is all dark nebula in here. There's all dark dust in here. Think of this nebula as continuing all the way to here and beyond, but this area right here is actually blocking it, and then it goes around here, and this is just sort of showing through, but this is an area covering the front. All right, and so this and this are actually connected together. This part up here and this part in here are in the same location in space next to each other, though, and these clouds are blocking it, these dust clouds. This particular area, this can be likened to a blister on the surface of the skin, and so that's what this sort of looks like, right? And this nebula has got so much detail, it's amazing. And when we take pictures about like this speed, you really can't see the detail in here. But let's do this. Let's drop this down from 4,000 down to 1,600, and let's go only to 20 seconds. Okay? All right. Now we're going to do a 20-second shot for less than half of the sensitivity. Ronald, the filter I'm using here is a slightly wider narrowband filter than the other one that we use typically. So 20 seconds, what do we get? Well, let's find out. There's our 20-second shot. And we look at
Bill
it.
Murray.
Huh?
I said, there's Bill Murray.
Oh, see, now you're doing that again. Where's Bill Murray?
Never mind.
Oh, no, you're not getting away with this. You always say you see Bill Murray eating a Baby Ruth candy bar. I see Dark Nebula and the Trapezium, which are these 4 stars.
Yeah. Hey, I was an art major in college, so.
Yeah. Well, you know what? I actually was an astronomer, but I also got a minor in art as well. Because I thought the beauty of the universe needed to be spread and spread to people, right? And that's why you're doing it too, probably.
Sure.
This area in here, guys, this part here, these 4 stars power this region. Okay, these are the powerhouse stars, 4 young hot stars in the trapezium, and they're called the trapezium because it looks like a trapezoid, and they light up and cause the hydrogen gas to excite in here and glow red like this, but then they scatter light in here. And that scattered light that you see in the middle of the nebula is what we see as this greenish blue in the middle here. But it's really incredible. We can actually, I might be able to draw just a little bit more information out of this for you here. Just a second here. Let's see.
You know, if not Bill Murray, I could also see Barney from The Simpsons when he belches. You know, when he drinks beer.
Yeah. Hey Homer, look, a peanut. Yeah, right. And his lips all go
The way his
all
lips move, you know, when he burps.
They flap.
Yeah.
Remember once Barney fell into a garbage can, and he burps there and goes, "Hey Homer, look, a peanut." Gross. That's very funny. Okay, so yeah, I'm just adding a little extra detail here, and I think it's too much. Pull it down. Oh, this will work. Okay, so I added a little detail just to kind of help sharpen it up a little bit. Right, but you can see this modeling in the middle, and that's really because there's so much going on in here. There's so many other objects in this. There are things called Pleyades, which are protoplanetary disks, which is what that stands for. And there's plenty of them in this nebula. So seeing Pleyades is a very important thing for trying to decipher what's going on with life in the universe, you know? And this nebula's got it all. Yeah, like my big glass. Okay, so now let's go the opposite way, and let's now do the following. Let's take this up. We're going to go nuclear now. 12,800 for 1 minute. Okay. We're going nuclear on the nebula. It'll be a nuclear nebula. And by the way, there's no nebula called the Nuclear Nebula. I think that'd be pretty cool.
I assume an infrared image of the Orion Nebula would show a lot more stars.
As a matter of fact, and what happens is, and the reason why Daryl, I think, is saying that, guys, is because infrared telescopes you rarely find, if at all, on the ground. We don't have any on the Earth that are like at sea level. They can only work at very high altitudes, and preferably in space, because infrared is stopped by our atmosphere pretty effectively. And if it didn't work that way, we wouldn't have a greenhouse effect in particular working on us. Oh man. Because we would have all the heat that got manufactured and generated from all the stuff on the Earth would go back out into space, and it doesn't. It gets trapped by the atmosphere. Wow, look at that, huh? Well, there's the full extent of the Orion Nebula. You can see it. Now it's a little more clear about how this object is being occluded by this, and this dust is like sticking out a little bit over the bright central core of this nebula. Pretty amazing, huh?
Mm-hmm.
Really is pretty. The Orion Nebula never gets old. Another place that doesn't get old is just north of the Orion Nebula. Daryl knows what I was saying. Daryl knows what that is.
Yep.
So let's head up there. And no, we're not going too slowly, because we're going to get there in a moment. And we're getting there. Yep. Now we'll just do a short photo. First, we'll do, say, 25 seconds at 12,800. go. So you guys having a good time? Hey, Trish. Oh, yeah. And we have a running man. We're still getting a little of the dome in here. That's got to be like an edge. It's beautiful. So that was 30 seconds. Now what we're going to do is crank this up to 51,200 and go for a full minute. Okay, now while it's doing that, I'm going to run out and make sure that the dome isn't interfering, because I see that red and that tells me it's interfering. All right?
Okie dokie.
All right, so I'll take a picture and I'll be right back.
Adam, the dust we see that's making the dark clouds, I would assume it's mostly carbon. Other things too, though. I'm sorry, I'm not very talkative tonight. If you see really deep exposures of Orion, it is just, especially the lower half, I think, is just full of dust clouds. And all sorts of material in there. The dust, carbon, probably silicon, you name it. Hydrogen gas, of course. And that's what's making the stellar nursery out of it. And the succeeding generations of stars are also sort of reseeding material back into the dust cloud. Mark has talked about Barnard's Loop before. If you see deep exposure of the entire constellation, at the lower left part of the constellation, you'll see a big red hoop like a semicircle. And that's called Barnard's Loop, and that is from a prior supernova in the same area, if I remember correctly.
Okay.
Stars have been cooking up and living and being born and dying there for a long time.
Yeah. That is true. I'll take one more like this. Okay, one more. 1 minute. This nebula, as Daryl may have said, is also called a reflection nebula. You can see the bright blue, again, dust that is scattering the starlight in all directions, and only pretty much the high frequencies. But also in here, this red doesn't belong in there. That's actually, I had a slight edge of the dome in there, which is what that was about, and it shouldn't be there in this next shot. But you also see a little red up in here, and that actually is in the nebula. And some of the most beautiful photos that we've taken are of these nebulae that are what we call hybrids. They actually have multiple colors in them because of the different nature of what's going on chemically. Just it's outstanding. Yeah, see, now you can see that blue is all by itself now, and you can see more of the red up there near the center. Can you see the running man is the question. This is called the Running Man Nebula. Can you see the running man? Dun, dun, dun. I don't know if anyone can see the running man, Daryl.
Well, I see the general shape of that. It has a human shape to it, and I guess he's running.
Yep.
He might be wearing a cape and flying, or you know, there's a bump at the top part, sort of in the middle, and I guess that's his head. And then he's got one arm to the left and one arm to the right, which kind of looks like the cape to me because it's fatter. And then his legs down below, and one is to the left and one is to the right. And the one on the right, I see a little crook in it, like maybe his knee. I could visualize a running man there, I guess.
Yeah.
Is that what I'm supposed to see?
I think you are.
Yeah.
I do think you are. And I guess to see what this looks like, to see what this looks like processed. Let's go back to our not that view. That's my telescope view. Well, might as well let you see that too. So that's where we're looking in the dome. That's the cover of the telescope. The thing that I wanted to show you here is right here. This is the running man as it appears when we process it, and you can see that this particular object is really quite beautiful. This area here, okay, you can actually see how it's almost in 3D. It's a 3D protuberance of dust, okay, that has a narrow neck where the light from these beautiful stars is sort of filtering through. Here's the rest of the dust. This is the processed photo from the running man. Let me see if there's any other options I can do here for you to show this. We can do this.
Running man is also known as M43, is it not?
I thought that was a little piece above Orion. This is NGC 1977, isn't it?
Okay. M43 is just under the nebula, right?
Yeah,
Sort of.
that's correct. Right, yeah. Yeah, you got 1977, which is this guy. And then you have M43, and then you have M42. But
Ronald asked a question a minute ago.
Ronald always asks questions.
I can't see it now.
Who does he think he is, asking questions all the time?
Ronald, I assume you were talking about the Orion Nebula itself. Daryl, on a regular view, would it be washed out compared to filter usage? No. Depending on your location, though, if you were in a nice dark sky, it would not be washed out at all. It's stunning in the eyepiece from a dark sky location. You just see tons and oodles of detail.
Yeah.
And it may look green to you. It always looks green to me, but it all depends. If you're viewing from a city, certainly it'll probably be washed out to a great extent. You can only see the brighter parts of the nebula then.
Yep. But you can certainly see the difference between the live view here and the processed final image.
Mm-hmm.
Look what we do. I mean, this is just amazing stuff. So this is cool. And I'd like to take us now to, we'll just keep on going up the hill, shall we?
Going to the horse head?
Yeah. We'll keep going up the hill. So, we'll tell it to go to the horse head. You'll see the stars zip away as we've told the telescope to begin the high precision process to locate the Horsehead Nebula for us. So this star here is the star that it's picked as its high precision star. That is that star right there. And then it centers it and then it brings the object that we want to the spot where that star is going to be in, right about there. And now, like a magic trick, you'll see the star just vanish. Well, you saw it go. But that's because it's bringing in the other object that we need to see. And that's the Horsehead. And we will get to see Daryl's favorite star system again, I think.
Sigma?
Yeah.
Yeah, one of my favorites.
All right.
Really cool, multiple star.
Oh, yeah.
And if we do get to see it, Sigma Orion is what is actually illuminating the dust clouds that you see the Horsehead against.
Okay, well, I believe it's about 37 degrees above the horizon. Let's check. Okay, no, I was wrong. It's only 32.5 degrees above the horizon. Right now, it'll get much higher above the horizon. It looks much better. Isabella Melamed, how are you? Welcome.
Hello, Isabella.
Isabella's a superstar. She took 2 of the SkyTour photos and enlarged them and put them up as prints on her walls. Oh, right there. Look at that. Right dead center is the Horsehead. There it is. You know what I want to do, don't you?
I'm almost afraid to ask.
Mm-hmm.
Stack some images?
Not right now, but yes, I'm going to be able to. It's not high enough above the horizon to try this. But hello, Isabella. But I'm going to do 1-minute shots of the Horsehead, and I will be stacking them to see the amazing detail. But first, I want to bring us over a little more. See? Right there. Right down there at the lower right. That is Sigma Orionis. It's a beautiful star system. It's actually a multiple star system. And it's a very, very hot star. And what you find is that it's providing, as Daryl had mentioned just moments ago, it's providing all of the energy that lights up this back diffuse hydrogen wall. Okay, and this is a dark nebula coming out of all the rest of this dark nebula. This is all dark nebula in here. How do we know? Check it out. Here's a reflection nebula. This is a star that is actually bright enough to scatter a lot of the beautiful light from this dust in here and show itself through the dust cloud. Isn't that crazy? I think that's pretty cool. Yep, and let's see if I can get another better shot of this nebula.
Excuse me just a moment, please.
Absolutely. I'm going to go down 1 and do 1 minute. Somebody getting another pet in the chat that I missed? All right. Okay. This should take us to I did a 30-second shot using a camera on a tripod of this region of space out in Arizona, and the image, well, it stands alone. Okay. Wow, that's really pretty. And you can see Sigma Orionis off to the right there. Okay, up there. Very bright, hot and blue. And another view of it is right here. This is a 30-second photo taken with a camera on a telephoto on a tripod.
You took that?
That's the one from the pad in Arizona.
Oh, cool.
Yep. That was the one that basically told me that I was probably going to end up, I was going to be living out there, because this was just such a beautiful scene. That's gorgeous. And you'll notice that you see these dashes right here? Dashes.
Tumbling rocket body or satellite.
You got it. A tumbling rocket body. Yeah. Yeah. Pretty cool. So this is the Horsehead Nebula right here. You can see it. Okay. There's our little tumbler. Dash, dash, dash. Okay. And then Sigma Orion out here. And this is that beautiful diffuse hydrogen wall outside of this gigantic cloud. So what is this giant cloud? Okay. This giant cloud is called the OMC. Actually, the OMCC. The Orion Molecular Cloud Complex. And it's really got a lot of very interesting stuff going on in there, especially because it's molecules of material in there rather than just atoms. Holy cow, just something. Isabella, yes. But don't worry, Isabella, we'll get you some more. This is the one that this is actually the earlier nebula that I took months and months ago. Okay? And I used my standard technique that I used to grab nebulas like this to get that image. But the newest images that I took just the other night, that nebula that you're looking at on the screen, let me show you what it really looks like. You ready? This is what it really looks like. Look how much more detail. I did that using that technique I've been talking to you about all night, by using that very, very high sensitivity, high ISO, and then using a special artificial intelligence algorithm to remove the noise. It's magic, folks. It's magic. You know. So that said, that's pretty cool. Now, our last stop for the evening, before I need to go to bed, I've been packing Pelican cases all day long of equipment to go on the shoot for, because it's a shoot that we're going to talk about paranormal and interdimensional travel and UFOs, and it's going to take place in Hudson Valley, New York. It's just incredible. So let's go back to our main screen, and you can't see it, but the Horsehead Nebula is right here. This is what you see with your eyes. So if you were out there in a spacecraft, you still wouldn't see it. You'd fly right through it. Poof. And you wouldn't even see it. It's pretty cool. Okay, the last stop for tonight is this beautiful location. And first things first, we're going to head up to the leftmost star in the belt of Orion. This is the belt of Orion here. This is Alnitak, this is Alnilam, and this is Mintaka. Interesting thing about these stars, when Lucy, and I've talked about this before, which is Australopithecus afarensis, when Lucy was in Olduvai Gorge 4.2 million years ago, tooling around, had Lucy looked up at Orion, at the proper point in the season, she would have not seen the Orion we see today. Because some of these stars weren't even born yet. Some of these stars are only a few million years old. So that's pretty cool. See? That's pretty cool. So, let's go and let's make our way up. Once again, we'll go north, young man, and we will find the star Alnitak.
I know where you're headed.
I know you do. So this star right here, which is going to keep right on going unless I stop the telescope. This is Alnitak. And we're going to head east just a little bit. And you'll say, well, wait, why are you moving Alnitak off the view? Because we have to for this particular view. 40,000 for 30 seconds. Let's enjoy the next few moments, shall we? There's another nebula here hiding right in front of you, hiding in plain sight. And I'll show you that. Okay. So the Horsehead is here, and Sigma Orion is in this beautiful little reflection nebula. And then right above all this, Alnitak is out of the view by about 6 inches. We have this guy. Look at that. Now Alnitak creates these amazing these amazing things. This is not a bubble of gas around this nebula. It's a lens flare from Alnitak. But look at that. That is the Flame Nebula. When you look at the flame, you see these dark lanes in there. These dark lanes are, again, dark material that's in front of the brighter nebula behind them. All right, and they're occluding it. They're causing it to be obstructed. I think that's a beautiful nebula. I'm not still.
I've asked this before.
Yeah, go ahead.
The flame is a notably different color than that silhouetting the Horsehead.
You have said that, and it's actually true. Yeah, you say it looks like it's golden in color versus red.
Yeah.
And when we look at the flame, tonight it looks like it might be reddish, but you're right. When we take pictures, okay, especially pictures like this picture. No, not this picture.
Telephoto image you had up earlier?
Yes. Yeah. Of the Horsehead. Yeah. You can definitely see that there is a difference.
To what would you ascribe that?
I can only think that it has to do, because it really is. It really has to do with. This is the one you're talking about.
Yeah.
I think it really has to do with the amount of dust between us and the actual flame. It could be something like the dust area there is less, or there's more hydrogen excitation going on, or less excitation, and maybe there's other chemistry in this nebula that are adding a different set of colors into the mix. I don't know, and it's probably that. This is hydrogen that's being excited by Sigma over here. Okay, that's what this red glows from. But this reddish golden glow, there might be something else going on here. There might be another chemical, another element present out here that is making it, making it have that effect. I do not.
Is Alnitak what is illuminating the Flame Nebula?
I don't remember. I think it is, but I can be wrong. I mean, because space is 3D, we don't really know. I think Alnitak, though, is illuminating the flame.
Why don't I find out?
Okay. Alnitak is actually causing the hydrogen to excite enough to ionize in the flame, if that's what it is. And then when those electrons jump off there, they're ionized. When they go back and rejoin, then they give off light, which we see as this characteristic red. But maybe there's other transitions going on that we're missing to explain the color.
Yes, Alnitak. Alnitak shines energetic ultraviolet light into the flame, and this knocks electrons away from the great clouds of hydrogen gas that reside there.
Oh, yeah.
So it is what's lighting up the flame.
Yeah, and that's the ionization and recombination when it goes back. Well, there's our new view of the flame. Okay. Alnitak naturally giving us our beautiful little lens flares, putting it in a bubble. Amazing. Very stunning. Very stunning.
Somebody asked in chat a little while ago if there are planets in Orion, and according to this, the center of the Flame Nebula is a cluster of newly formed stars, 86% of which have circumstellar disks.
Oh.
X-ray observations by the Chandra Observatory show several hundred young stars out of an estimated population of 800. So there's actually 800 stars going on in there.
Yeah. And they're actually stars that are very young, so some of them might not have their light leaving the nebula yet. It might still be in their protostar stage where they're still infrared hotspots and not winked on yet as stars.
Yeah, and I would wonder at the center they talked about is probably behind the dark cloud.
Maybe.
Well, they said they had to see them in X-rays to do it, so
Yeah.
sort of like what I wondered earlier about, infrared imaging as opposed to visual imaging if they saw through the dust cloud there.
Well, that's how they typically see young stars in these clouds, is with the infrared, sure. And Spitzer Space Telescope did that for us. IRAS did, IRAS. And then James Webb Space Telescope will be doing that next for us. You know, because the James Webb is all infrared. It's a total infrared telescope.
Knock on wood.
Yeah, it just has to get launched. But that's but guys, that's it for SkyTour tonight. I'm gonna have to call it a night, and just so you know, like I said, I mentioned before, it looks like this may be the last time we stream in this telescope in Connecticut. The next time you see SkyTour LiveStream, we're going to be streaming from Arizona, I hope. And because we're going to be dismantling this observatory to refurbish it, to rehab it, and to replace the dome with a roll-off roof. But that's in Connecticut, and the telescope to put in there is sitting behind me. It won't be empty. We're going to have a telescope going right in, and it's going to basically replace what's being taken out of there to go to Arizona. This telescope here is the one we'll have in Arizona. So the one you've come to see, the one you've enjoyed, and I will be running it from 2,400 miles away initially, and then I'll be running it from about 70 miles away once I actually get out there.
You know what I think?
What's that?
You gotta mortgage your house or something and get you like about a 30 or 40 inch plane wave telescope and put in that observatory.
I would love a plane wave. Yeah. Look up plane wave, guys, and see what Daryl's talking about. I might just opt for an astrograph.
Yeah.
You know, as much more expensive as it is, it's a lot cheaper than a plane wave. But
one can dream.
That's true. If I get a foundation to support me, well then, plane wave it is. In fact, a whole new building it is too. You know, just imagine this 5-acre spread. What if we were to put, well, I don't know, 5, 6 buildings on the property, some larger than others, with a variety of telescopes, and have different universities run programs from the desert? Now you get it. That'd be kind of cool. Ladies and gentlemen, boys and girls, and you, Daryl.
Haha.
I know, right? Thanks for coming and enjoying this time with us. We had a great time with you tonight. I want to thank you, Daryl, for taking the time to come out tonight. We had a good time.
Oh, sure.
And we will be back, well, I would like to say normally on the next clear night, but I'm disappearing for 13 days. And then when I come back, everything that made all these images possible is being shipped to Arizona. I'm committed to it. So now we're doing it. It's coming. It's happening. And the observatory roof, I left a Facebook post for those on Facebook, a video showing the roof going on and off. And it really is smooth, and it's quiet, and it's really just so easy to interface with. So we're going to be doing that. I wrote the software. I got all the system out in the dome here. I did all the troubleshooting out here first. So when it gets out there, it shouldn't know the difference, except for the latitude. But you guys, you have a good night, and we will talk to you. Well, I will be streaming from New York. I'm going to go, I will take some time to actually do a live stream or two out there of the whole process. Maybe I'll live stream the end of the day, say, hey, well, today here's what we did, you know, that kind of thing, and give you an idea of what we did. All right? I'll be working with a guy named Ben Hansen and Melissa Tittle, and they are amazing people, good people. Ben and I have known each other for many years, and the Travel Channel folks didn't even know that we knew each other when they cast me for this position. So I thought that was pretty cool. So we're going to do some pretty neat stuff, and when I get an idea from them how much I can tell you we do, or tell you what we can do and what we're going to do, then I will. So I'll spill the beans if I can in the live streams out in New York, okay? So I look forward to talking to you guys again. Look, I just don't like saying SkyTour LiveStream has to go down for a little while. It just sounds terrible. But it's going down only for the time it takes to make it better. And that's going to be for a week at the end of the month, you know.
SkyTour LiveStream Mark II.
Yeah, well, yeah. I just say SkyTour West, you know. I don't need my name in there. That's very cool. You guys are wonderful. Thank you so much for coming out. I look forward to seeing you guys again. You guys have a good night, okay? I'll see you later.
Night, everybody.